we have some bits inside the pistons and whatever. So in short, that's our engine. Right, so components. Right, the first component which we are going to talk about is the piston, which is this here. Right, so piston, like we said, made of aluminium. Remember the properties of aluminium, because it is light, because the pistons, they have to go up and down at tremendous speed. For example, what can I say? At about 3,000 revs a minute, the crankshaft, at what speed will be that? About 60 miles an hour. So this piston, you can imagine how many times it is going up and down. So if it was made of cast iron, then it would drag. So it is made of aluminium to keep it light. Also, other properties of aluminium we talked about, it is a good conductor of heat. So the piston is able to dissipate heat. So that is another property. Right, so the piston, on the piston, this top part of the piston, we call it the piston crown, as in the queen's crown. Then that bit there, we call it the skirt, as in ladies' skirt. Right, then we have these grooves. Inside the grooves, we have what are known as piston rings. We clear them. So small engines, they have smaller pistons. And also the top of the pistons, it varies according to the engines. Some pistons, they can have a flat crown. Then we have circles for valves, or we can call them valve recesses. So much so that the valve recesses, when the valve is open, if we have a recess, the valve is not going to hit the top of the piston. So we'll be having some recesses at the top of the piston. Some pistons will have a slot on the side. The purpose of that slot is for expansion, because the piston, it gets very, very hot. So some have got slots. The purpose of that slot will be for expansion. The deflector, like we saw on the two-stroke cycle, like this piston, it has got a deflector. Then large engines, like diesel engines, we can get a piston as big as this one. Ring belt, the skirt, the piston crown, and so on. This is an example of a piston where the engine overheated, the piston melted, the valve melted, and it on the piston. Maybe the mechanic forgot to put water in the radiator or what. Right? So that is the damage which can happen to a piston. Also, as we discuss further, you will find if the timing belt snaps, the piston, the valves will hit the top of the piston and the engine will be effed or finished. F for finished. Right? So, on the piston, we have two types of rings. The two top rings, we call them compression rings. Then we have, maybe some pistons can have one, like the smaller ones, they'll be having 2 and 1. Right? The bottom one, this one is got 2. The bottom one, it is called oil scraper ring. If you can see on the bottom, we have some holes. So the oil is scraped on the cylinders. As the oil drips through the cylinders, the piston rings will scrape the excess oil. Then the compression rings, remember during compression, they help in sealing the cylinder so that no gas will escape. So compression rings to seal the cylinder, prevent gases escaping. Also, oil scraper rings to act as oil control or scrape the excess oil. At the end of the day, if the oil scraper rings are defective, broken, are worn out, what do you think will happen?
The oil in the mixture, isn't it?
Anything else? Oil will?
Get in the mixture. You oil to suck it back into the crank.
Yes, we can have excessive oil consumption, black smoke out through the exhaust, too much oil going into the crankcase. And what will happen if the compression rings are worn out? Loss of compression. During the compression stroke, no compression, loss of power, the engine is not going to pull. So that's the piston. Right, on the piston, we have that wall there. This wall, through that wall, we have a pin which is known as a gudgeon pin. Right, the gudgeon pin will connect the piston. Can you see through there? We have a pin which is the gudgeon pin, which will connect the piston to the piston leg, which we call the connecting rod. So that pin connects that to the leg, right, which is the connecting rod. Then the connecting rod is attached to the crankshaft. So much so that as this will be turning, the pistons will be going up and down. So we have a piston, a gudgeon pin, a connecting rod, and crankshaft. Now it's spelling for gudgeon pin. So that's the connection. Are we clear on the piston? So at the end of the day, the function or the purpose of the piston is it acts as a gas-tight plunger inside the cylinder, and also it transfers the force. Remember, during the power stroke, it transfers that force through the connecting rod to the crankshaft. Happy with what the piston does or why you need one in the engine. Then the connecting rod, its purpose, it connects, in simple terms, the piston to the crankshaft. Do you want to be writing those simple statements, or you read and whatever, understand? So connecting rod connects the piston to the crankshaft, which is the major shaft in the engine. Are we happy with that? Right. What can I talk about next? Maybe crankshaft. I don't have, don't know. Yes, the Google changed the images, because if I try to go on Google Images, has it changed the whatever? Or maybe it's me on computers. Could be me. Just want to bring the image of a crankshaft because I do not have one. How do I click on this one?
Click on the one. Just click on one.
Is it big enough? How can I make it bigger?
Before that stuff.
How do I make it view?
Just click on the other image.
Not big enough?
Enlarge it.
It's a similar shape, but it's obviously
But
it's even bigger.
can I make it bigger?
Yeah, zoom in.
Right click. There's no zooming now. Someone can come and zoom it for us.
There might be a little tab at the bottom in the corner. Bottom right corner should be a tab where you can change.
You should be able to just use that mouse and just.
Use the mouse and do
I don't know if it's got the little rollies
Maybe.
and roll it and it get bigger in it.
It's not all, depends what you're using, but
Because if it is bigger, then
I know what you mean, it's like, where you do it.
yeah, or just make it bigger. If you cannot do it, then you just
Copy paste, put it
That's
on
what I
Word
said,
or something.
If you save it and then open it, you might
Yeah,
be
I know
able
it's
to.
probably wanna-
okay.
I can control them.
So okay, we'll just talk about it as it is. Then I'll show you on CDS the animation. Right.
You have to do that.
Right, the crankshaft, it is major shaft in the engine. Crankshaft. Right. What is connected to the crankshaft? What do we have connected to the crankshaft?
The connecting rod.
I got the
Conrod.
The connecting rod. Right. So on the crankshaft, if we look closely on the crankshaft, we have this one, that one, that one, that one, and this one. They are in line. Can we see this one, that one, that one, this one, and that one? We call them crankshaft main journals. Main journals, yes. Because they are along
Journals.
the axis of the crankshaft.
Journals. Like
Then, can you see that we have that one,
piston one,
that one, which is offset, this one,
piston
and
two.
this one? They are not along the center line of the crankshaft. We call these, the offset ones, the big end bearings, or big end journals, or crank pin. So we have big ends, then we have the mains. So the connecting rod is connected to the offset ones. Connecting rod there, connecting rod there, connecting rod there, connecting rod there. Can you see the setup?
1,
Remember-
4, 2, and 3.
yeah.
Yes, remember what I said about 1 and 4 married. Can you see that this journal is on line with this one? That is what makes 1 and 4 married. Then 2 and 3, they are at the same position. So at that position, 2 and 3, are they at TDC or BDC?
TDC.
TDC. Then these two, 1,
BDC.
4 and 1, they are at
BDC.
BDC. So it is the setup of those journals which makes the number 1 and 4 married, 2 and 3 married. Are we clear there? Right. On the crankshaft, we have these. We call them webs. They are there to balance the crankshaft so that it runs true. So they act as balance weights. These ones.
Webs.
Yes. Crank webs. At the end of the flywheel, at this end, we have the flywheel attached. So the flywheel is here. If you see on your sketch, we have a flywheel. So the flywheel is attached at the end of the crankshaft. Then the other thing, also on the crankshaft, we have, can you see some holes on each journal? Them holes are for oil, for lubrication. As the crankshaft turns, we'll be having oil coming from the lubrication system to lubricate the crankshaft. So them oil holes supply lubrication. So the crankshaft, as it is turning, we have oil to lubricate or to reduce the friction and wear. Are we clear there? At the other end of the crankshaft, that is where we have the crankshaft pulley or the timing gear. Then we have a small key which acts as a locking device, which is called a Woodruff key. this Woodruff key. So the Woodruff key will lock the crankshaft to the timing gear. We clear on crankshaft, piston, and connecting rod. Piston, connecting rod, crankshaft. Right, let's see what we have on CDX, then we can, before we give you a small break. Please stop me if you think I'm going too fast. Just tell me to stop. Plug-in is gone. Components. Which component did we start with? This one? Okay. Let's start with the piston.
The piston, with its connecting rod and bearing, transfers the force of the combustion and expansion of the power stroke to the crankshaft. The piston itself, its rings, and the piston or wrist pin are together called the piston assembly. The cutaway shape on this piston allows it to clear the counterweights on this rotating crankshaft. The shape of the piston crown depends on the shape of its combustion chamber and its compression ratio.
Okay, I forgot to mention something. On pistons for diesel engine, so this is an example of a piston of a diesel engine. Can you see we have a ball and this,
Recess.
yeah, a big ball. So for diesel engines, this ball, it acts as a combustion chamber. So the burning of the air fuel mixture happens in this
But it comes a lot
ball.
closer, isn't it?
Yeah. So most diesel engines, they have a ball on the piston.
Oh, I've got a question. What's the job of the flywheel?
The flywheel, it keeps the momentum of the engine because it's a heavy flywheel. So during the non-firing strokes or when the engine is idling, the flywheel will keep the momentum because it is a heavy wheel. So it will keep things
Takes up
going.
slack of the other pistons.
So does it attach
Also-
to does it attach to anything else, or does it just sit there, just keeps like in
It
rotation?
is attached to the crankshaft.
Yeah.
So it
yeah.
keeps the
But it's not
momentum.
attached to anything else. It's just
Also the clutch plate is mounted on the flywheel.
yeah.
Also on the flywheel, you see there are teeth on the outside.
Yeah, that's what I asked.
Those teeth, they engage with the starter motor. When you turn the key on, the gears on the starter motor will, with
Into
the
the
flywheel,
flywheel.
then cause the flywheel to start
Just kick
turning.
off the crankshaft and then
Yes.
stop.
Mhm.
Okay.
You know what happens when you continue to turn the key on, it goes, yeah, it is the flywheel and the starter motor meshing. Right.
The piston crown may be flat, concave, domed, or recessed.
Who's this?
In diesel engines, the combustion chamber may be formed totally or in part in the piston crown, depending on the method of injection, so they use pistons with different shapes. The piston must stand up to great heat and pressure. It also must change direction from about 10 times a second up to hundreds of times a second. In most engines, the weight of the pistons is important for engine balance. This is why pistons should only be replaced in matched sets. Some pistons are forged, while others are cast aluminum alloys. All pistons expand as they heat up. As there is more metal near the gudgeon pin, also known as a wrist pin, this area tends to expand the most. To allow for this, many pistons are machined into a slightly oval shape. This is called cam grinding. Then, as the piston heats up and expands, it becomes round. Other methods to control expansion include steel struts or ribs, expansion slots in the skirt, or slots called heat dams that restrict movement of the heat. connecting rod connects the piston to the crankshaft. It is fastened to the piston at its little end by a piston pin, also known as a wrist pin. In some engines, the pin is a press fit in the small end of the connecting rod. In others, it is clamped to the connecting rod with a clamping bolt. Another method lets the pin float in both the piston and connecting rod, and it is held with circlips. There is a bearing in the small end of the connecting rod. The big end of the connecting rod has a detachable cap and carries 2 halves of the big end bearing. The big end is attached to the crankshaft at the crank pin journal. Connecting rods must be very strong and rigid, and as light as possible. They are subject to stretching, compressing, and bending, so they are highly stressed. They are cast or forged to form an H near the small end and an I near the big end. This shape provides greater strength to resist the stresses than a solid rod of the same mass. To maintain engine balance, all the connecting rods in an engine are a matched set.
Okay, I'll do crankshaft.
The piston, with its connecting rod and bearing, transfers the force of the combustion and expansion of the power stroke
You've seen
to
this
the
one,
crankshaft.
Okay,
The piston itself, its rings, and the
right. We do crankshaft quickly, then we can go for the smoke break.
So when it takes, so the piston takes the power over to the crankshaft, yeah?
Yes.
And what does the crankshaft do after?
What does the camshaft do?
Yeah.
The camshaft, the purpose of the camshaft, it opens the valves. I'm going to talk about the camshaft.
Wait, what's it taking to? The camshaft or the crankshaft?
What is
Camshaft.
Crankshaft's at the bottom, camshaft's at the top.
So, crankshaft, right?
Can we do the crankshaft, flywheel, and cylinder block, or you want to go for a fair?
What's the time?
10 to 8,
Yeah, I don't mind.
fair.
Yeah.